In this section, we're going to take a look at the harmonic series, which is a very important series, and it's very important to know that it diverges. It's the infinite sum from n equals 1 to infinity of 1 over n. So it's 1 over 1, which is 1 plus 1/2 plus 1/3 plus a quarter, etc., etc. To see why this diverges, we're going to look at some of the partial sums. And we're going to show that the partial sums grow without bound, so we can make them as large as we like. And we're just going to focus on a subsequence of the partial sums. We'll start with S1, which is 1. So the sum of positive terms is at least 1. It's greater than or equal to 1. And the second partial sum, S2, is 1 plus 1/2, which is 3 over 2. So we know that if this series converges, the sum is bigger than 3 over 2. Now the fourth partial sum is 1 plus 1/2 plus 1 over 3 plus 1 over 4. But notice these last two terms add up to something greater than 1 over 4 plus 1 over 4, which is greater than 1/2. So this fourth partial sum is bigger than our previous one, 3 over 2 plus 1/2, so it's bigger than 2. So we know that this series, if it sums to anything finite, that thing must be bigger than 2. And now let's add in the next four terms. And we see that they are 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8. And all of these are bigger than or equal to 1 over 8. So the sum of those four terms is also bigger than 1/2. And now the eighth partial sum is bigger than our previous one, S4, plus 1/2. So it's bigger than 5 over 2. And we can keep going like this. We add in the next 8 terms, and we see that the 16th partial sum is bigger than 3, etc., etc. And we see that the 2 to the nth partial sum is going to be bigger than n plus 2 over 2, but we can make that n as big as we like. So these partial sums increase without bound. So the limit as n goes to infinity of the 2 to the nth partial sums, or the nth partial sums, is bigger than the limit as n goes to infinity of n plus 2 over 2, which is infinity. So this series diverges, does not converge to a finite sum. Here's something we should note, that convergence or divergence of a series is unaffected by adding or deleting a finite number of terms of the series. So the actual sum, if it exists, is affected by adding or deleting the first few terms of the series, but the question of whether it converges or diverges, the answer to that is unaffected by what happens with the first few terms. So for example, since we know that the sum from 1 to infinity of 1 over n is divergent, we also know that the sum from 10 to infinity of 1 over n is divergent. And since we know that the sum from 1 to infinity of 1 over 2 to the k is convergent, we also know that the sum from 50 to infinity of 1 over 2 to the k is convergent.